Hi, welcome to your first flip video for topic 10. Topic 10 is all about angles, and 10.1 is about measuring angles. So part of what 10.1 is using a protractor to measure angles. I'm going to skip that for this video just because I don't have a good digital protractor tool to use. So let's go ahead and get started with the actual stuff. So if I have this angle, we're talking about measuring angles and labeling angles and working with angles, and you have all these points on it, I have a couple of different names for this angle. Some of them might include, so that inside angle right there. So angle XZV, or angle YZV, or angle XZW, or angle YZW. So when I look at that, what pattern do I see? I see Z is the middle variable for all of those angle names. And why is Z the middle variable? Well, it's because it's the vertex. So the vertex in an angle is the central point of the angle. It's that if you think about a door swinging and that the swinging door making a new angle, the vertex is your hinges. So Z is my vertex. That's the center of my angle. And so when we list out names of angles, we always put the vertex in the middle. So when you see XZV, what it's saying is go from X to Z to V. When you see YZV, that means Y to Z to V. When you see XZW, X to Z to W. And notice that they're all the same angle because all of these points lie on the angle, okay? So the first line, the first variable is always one point on a line that makes up the angle. The second point is always the vertex. And then the third point is a point on the line that's part of the angle but wasn't that first line. So if this was my first line, then my second line would be this one. Okay, so that's how we name angles, and that's important because that helps us identify what angles we're talking about, which we'll need. So let's look at the different types of angles. So we have 4 categories of angles that we're going to talk about, and there are more categories, but this is for right now all we're going to talk about. So the first one is a straight angle, and I started with this one because it's the most simple version, because everyone knows what a straight angle is. It's an angle that's exactly 180 degrees. So it's a straight line, basically. It's the angle made by a straight line. So if you have a straight line, it's the angle formed. And you'll notice that it's symmetrical on top and on bottom. A straight angle, when you have a line, is the same on top and the same on bottom. So straight angle is the 180 degrees. It has to be exactly 180 degrees. Another category is the right angle. And this is the angle that is exactly 90 degrees. And we show this by putting a little box in the corner of the angle to show that it is a 90-degree angle. And it doesn't have to be oriented like that. It could also be oriented like that. All that matters is it has the box in the corner, and that means it's a right angle. All right, another example would be an acute angle. Now, an acute angle has to be greater than 0 degrees, so it can't be a negative angle, and it has to be less than a right angle, so less than 90 degrees. And this could look something like that, or like that. So either the little one or the bigger one, both of them are still less than 90, so they're both technically acute angles. The final category we're going to talk about is obtuse angles, and these are angles that are bigger than 90 but less than a straight angle. There's a different name for angles that are bigger than a straight angle, and maybe we'll talk about that later, but for right now, obtuse angles, anything between 90 and 180. So example would look something like that. So either the first green arrow or the second green arrow, either one of those two would be obtuse angles. Okay, so let's say I have this angle, and I tell you that is 2x minus 12, and angle XYZ is also 160 degrees. Well, because the angle is 160 degrees, and it's also 2x minus 12, that means that those two things must be equal to each other. So I can use this information to make an equation and then solve for x. So 2x minus 12 equals 160. Solve for x. How do you get x by itself? Add 12 to both sides. Those 12s cancel. You get 2x equals 172. Divide each side by 2. Those 2's on the left cancel. X is equal to 86. So notice it's not degrees, because I'm not saying the angle XYZ is 86 degrees. I'm saying the variable x in the scenario is 86. So that variable x has a value of 86. If you have another example that looks like this, angle ABC equals 3x minus 30, you might say, well, I don't have enough information to solve that. I don't know another thing ABC is equal to. Well, yes, you do. You have that box in the corner, in the bottom left corner, so you know it must be a 90-degree angle. So 3x minus 30 is equal to 90 degrees. So get x by itself, add 30 to both sides. Those 30s on the left cancel out. You get 3x is equal to 120. Divide each side by 3. Those 3's on the left cancel out. X is equal to 40. So not saying x is 40 degrees. X has a value of 40. So for this one, let's look at a more complex example. So you have vertices A, B, C, D, E, all with a vertex of point F. I'm going to give you a lot of information. I'm going to tell you angle AFE is 270 degrees, angle CFB is 2x plus 1, angle DFC is x minus 1, and angle DFE is equal to 3x. And I want to know two things. I want to know angle AFE and what the variable x is equal to in this scenario. So let me clarify. So AFE, the 270 that I gave you, is that angle, so the inside angle. So we're only talking about obtuse angles, anything less than 120, and I gave you an example which is more than that. So I'm just going to clarify the AFE angle being 270 is that one. So when I say I want you to find AFE as one of the problems, I really mean find the outside of AFE. So if we do that, what's the outside of AFE? What is the opposite part of that? Well, if you combine the AFE, that's 270, and the piece that we're looking for, that makes a full circle. How many degrees are in a full circle? 360 degrees. So angle AFE, the outside portion, is equal to 360 minus the inside portion. We could also say that angle AFE, and I'll use inside, little I, plus angle AFE outside is equal to 360, and I know that the inside is 270, and then I could solve for this outside portion. But since we already have 360 minus 270, let's just go ahead and evaluate that. So angle AFE on the outside is equal to 90 degrees. So it doesn't look like 90 degrees, right? This right here definitely does not look like 90 degrees. So what I'm going to do is I'm going to say not drawn to scale. And that means that the picture might look different than the variable amounts that they are. You'll see this a lot on standardized tests, not drawn to scale, because the pictures don't accurately represent the scenario. It's not drawn to scale. 1 degree doesn't look like 1 degree. Okay, so let's now break down and figure out how to figure out x. So I'm going to go ahead and label what I know. I know CFB is 2x plus 1, so that's that red. DFC is x minus 1, the green. And then DFE is 3x, and that's the blue. So I can go ahead and put in all that information I know. Now, I know that all those angles together, well, let me talk about AFB first, has the right angle symbol, so it must be 90 degrees. All right, so now I know that all of those pieces together will add up to AFE, right? The red angle plus the green angle plus the blue angle plus that 90 degrees give me AFE on the inside. And I know what AFE is equal to. It's equal to 270. So let's set up an equation and then solve for x. So AFE is that right angle, AFB plus BFC plus CFD plus DFE, and I know what all of those are, so I can plug them in. So let's do that. So 270 is AFE on the inside, AFB is 90, and then 2x plus 1 is BFC, CFD is x minus 1, I'll put parentheses around those, and then DFE is 3x. That's just a long equation. We can solve that. Let's go ahead and do that. So I'm going to move it over here, and then let's combine like terms. So I'll do all the constants in yellows and all the variables and their coefficients in blue. And now let's just rearrange the pieces. 270 is equal to 90 plus 1 minus 1 plus 2x plus x plus 3x. Combine like terms. 90 plus 1 is 91 minus 1 is back to 90. So 270 equals 90 plus 2x plus 1x is 3x, plus another 3x is 6x, so plus 6x. And now we can get x by itself. Subtract 90 from both sides. Those cancel out. You're left with 180 equals 6x. Divide each side by 6. Those 6 cancel out, and you're left with 30 equals x, which means that x equals 30. So x is equal to 30. That is it for 10.1. Tomorrow we'll talk about adjacent angles and what those are and how they relate to this. Let me know if you have any questions.